Hi everybody, I'm Pete Cook, and this is the Hydrogen to Human series, in which we look at how just clouds of hydrogen at the beginning of the universe self-assemble into everything that we understand, going this way from simple to more complex. And that includes humans, the Hydrogen to Human series. In part 1, we looked at why, with a present perspective, we can't answer that question, because we can't get from physics into chemistry and biology, and we had real problems with entropy. Part 2, we solved that problem by having a dual perspective, that the universe is both a mathematical structure and a physical structure. Now, we've been looking at snowflakes for centuries. I cannot explain the mathematics, the symmetry, just using the physics. And now we do all of the physics at the base level. We have to do it in mathematics. It's all done looking at symmetries. That's mathematics. Ever since Benjamin Franklin introduced the notions of positive and negative in electrical charge, we have to use a combination of mathematical aspects and physical aspects. So we're going to say that physics is the energy. Physics is the energy that we can quantify. The qualities, how it behaves, whether it repels or attracts, are going to come from the mathematics. If it's positive and negative, I get mathematical rules which I can't see by measuring the quantities in the physics. The rules are, if they're the same, they repel. If they're different, they attract. So let's use our new perspective to start self-assembling the universe. And we're going to go right back to the time when there is no physical structure. Now, the two properties that we associate with physical structure are mass. We say something has mass and volume. But I'm going to show you today that both mass and volume are not intrinsic properties of the base units. Physics is energy. Now, I start with units we call the quarks and the leptons. Now, by themselves, quarks and leptons do not have any volume. Volume is a property which emerges from relationships between units of energy. If those units of energy attract and repel, I get something with volume, and the first one would be the proton. That does have a little tiny bit of volume. And that is coming from relationships, relativity between different kinds of quarks. The mass is brought along to the entities, the units of energy, by a relationship with the fields of energy, the Higgs field and the Higgs boson. So I've got fermions, bosons, and then fields. And fermions and bosons, the relationship between those two kinds of units of energy is what gives me quantum chromodynamics, or all the parts I need to build the nucleus of an atom. So both properties of matter, which we associate with physical matter, do not come from physical parts at all. I have a relationship which is complex, and I need units of energy where the energy is concentrated. I need the fields, and if the units and the fields affect each other, I get magnetic fields. So the unit becomes a magnet because of what's happening outside of it. So that's the same principle as general relativity. So it's all relativity between what's happening in the field what's happening in the unit, changing the behaviour of each other. I get 3 different kinds of energy. I get units of energy. I get fields of energy, and they change each other. And I get waves of energy. The unit can behave relative to the field as a wave or a unit. And I get strong and weak units, strong and weak fields. Magnetic fields are very, very strong, so they operate at the individual, at the atomic level. Gravitational fields are very weak, so they only operate at the collective level. So now I'm beginning to see a pattern. I've got 3 different kinds of energy: units, waves, and fields. And it's complex. They all act against each other to bring into the universe the properties of matter. Now let's just have a look at my little base units of energy, the quarks and the leptons, and its differences between units and fields, or units and units, fermions and bosons, which give me the forces. And we saw there are 3 pairs of forces. They only behave as forces relative to each other. So my quarks and leptons. Now let's have a look at my base pairs. We find Niels Bohr showed us the principle of complementarity, that down at the base I don't get individual units. I just get properties which come in pairs. Now that's a very, very important thing to understand. We've been looking for individual units, just physics is going to describe everything. And I get a pair of physics and the mathematics. So when I look down at the base, I get the quarks, and they come in pairs. I get up quarks and down quarks, and I get 3 lots of pairs. Strange and charmed, and then top and bottom. Doesn't seem to make any sense until you see it's a universal pattern. My leptons, which come in the same 3 lots of 2. And quarks and leptons can transmutate into each other. They're 2 manifestations of the same thing. Now, there are very, very good books on particle physics like this. And this book really just goes to unify all the different parts. It unifies the forces. I get the electroweak force. And it keeps saying in the book, one day the strong force and gravity all have to be put back together. But if I see the forces as coming in 4 forces, with the strong and weak forces not acting as a pair that build a nucleus, I've got the wrong pattern, so I can't solve the problem. My pattern here starts to build. I've got 2 kinds of quarks, but I need 3 kinds of quarks to build a proton. So I get a relationship between 2 and 3. The weak nuclear force, I need the W plus, the W minus, and the Z boson. Everything's come in 3s. My quarks have to be red, blue, and yellow. And this has to satisfy the quantum laws. So I'm going to use my base components, which come in pairs and 3s, to build the first composite particle. It's going to come out of the quark-gluon soup. Again, I just get a pair. Now here, in the proton, I get 2 up quarks, and they must be different to satisfy the Pauli exclusion principle, the quantum rules. I get the quantum rules and the classical rules. An electron behaves to both. When it's relative to an atom, it jumps, quantum jumps, numbers, quantum mechanics. In an electrical field, it spirals beautifully and smoothly. So everything comes in 2 pairs at the bottom, then I get 3 in a relationship between the 2s and 3s, self-assembles the universe. I get existence. A proton exists. Over here, it doesn't exist. So that gives me a completely new model of what existence is. I've got 1 of something that wasn't here before. 0 and a 1. It's starting to behave as a computational universe. A one new something that exists. It's not now a collection of quarks. It is a proton which has different properties. And I can use the same pattern again to build the neutron. And I've got to use the weak nuclear force to swap one into the other. I've got to use the strong nuclear force. And then I get the electron. And now I'm using the electromagnetic force. And I've got to use that electromagnetic force to build atomic nuclei, which again come in pairs, because if I don't have a relationship between electromagnetic repulsion and the strong and weak nuclear force, the atomic nuclei would just get bigger and bigger and bigger. Well, they don't. They stop at uranium, and that is unstable and it breaks back into two smaller nuclei. So here I've got a relationship. Again, now I can see a pattern. I've got 2 and an odd 1, and these two are related. I've got 2 and an odd 1, and these two are related. I've got protons, neutrons, and electrons. Now I've built the atom using the same pattern. And my energy comes in units, waves, and then something which is completely different, the field. So I've got the same pattern. And as we saw, the forces, I've got the gravitational force, which uses the two atomic forces to build a star. So let's now have a look at moving on from my protons, neutrons, electrons to build the first really complex system in the universe. Now, the classical way of looking at this is that the star made by gravity. Wrong. Wrong. Again, it's that simple answer with it's just a single notion that doesn't work, because if I try just to build a star with gravity, a relationship between matter and space, again, it's a relationship. I can't do it, because if I don't have something that acts against the gravity, I just build a black hole straight away. That's what happens when that is removed, when that opposite force is removed. So I've got to see what happens at the gravitational level as a relationship between what happens at the atomic level, releasing energy which is going to hold that star up. So I've got a push coming out of what's happening at the atomic level. I've got a pull from the relationship between matter, same matter, and space, but I've got something which acts at the individual level, that's the atomic forces, something which acts at the collective level, the strong and the weak. I can now see this is a feedback loop which has a ratio of equilibrium in the middle. So that's what physics is, it seeks equilibrium. But I've also got in the star, I've got turbulence. Now this is not physics. It's not described by the laws of physics. It's described by the laws of mathematics. But that's okay, because I've got now a mixture of the physics and the mathematics. So I've got the two parts of atomic physics. Two parts of atomic physics. I've got gravity, which is a relationship between the matter and the space, the fields and the units. So again, it's relativity causing gravity. And I've got non-linear mathematics, which is the energy being released from here, holding that star up. It's a system. Two kinds of physics, what happens at the very small scale, acting against what happens at the very large scale, and holding that star up, the energy, which becomes turbulent. So I've now got three parts of reality: quantum and classical, acting down here. General relativity, which is a relationship between matter and space, it's all pairs. And now I've got non-linear mathematics, describing the motion of the energy inside the star. So I've got my first simple system. It's not a dynamic system like the solar system, that's got another set of mathematical laws. It's not a complex system like the workings of a cell. It's just a system. It's complex by three different kinds of energy. It's complex. And in part two, we put together the mathematics and the physics and showed that the three different pairs of forces come in the same pattern as the three different pairs of numbers. And they come as strong and weak, which is symmetrical and asymmetrical. And if I look at the mathematical representation of fermions and bosons, one's symmetrical, one's asymmetrical. I've got odd numbers, even numbers. I've got electromagnetism, I've got positive numbers, negative numbers, and I've got real numbers and imaginary numbers. So I've got my real numbers, which are going to be strong and weak, imaginary numbers, strong and weak. I've got the units of energy which make the matter, units of energy which make radiation, photons, that's weak and strong, and mass is the weak field, gravity, the strong field, electromagnetic fields. Now this is really beginning to make sense because everything matches up. And then I've got the strong nuclear force, which comes in three different kinds of quark, and two different kinds of quark, up and down, red, blue and yellow. The weak nuclear force. The weak nuclear force. I've got two different kinds of lepton, and I've got three different kinds of boson that hold it all together. So now I've got an addition to my argon diagram, which brings in another pair. And that matches up with the three pairs of forces. So I can see it like a triangle like this: electromagnetism, strong and weak nuclear force, positive and negative numbers, odd and even numbers, a relationship between matter and space, real and imaginary. These are the real parts. These are the imaginary parts of space. So my units and waves are commensurable. They're commensurable with each other. That's what real and imaginary means. We can't experience space. We can experience what it does, but we can't experience it. So this little pattern here, where I've got two partners which are related, one opposite, the relationship between 2 and 3 is the relationship between the two first prime numbers. So the prime numbers, relationship between 2 and 3, bring a new 1. First prime number is not 1. So under the primes, I've got this random, I don't have 1 of anything, and that's what we find in the universe. I don't just find a electron, I find 2. And we already know that neutrinos can change into electrons. Quarks and leptons are all intertwined. When I change a proton into a neutron, I don't look inside here and see an electron and a neutron, but when I change one quark into another, two manifestations of the same thing, an electron and a neutrino come out. So I can say the relationship between the electron and the neutrino, the relativity, is the relationship between the two different kinds of quark. It's all relativity. What something is comes in a base pair, a conjugate pair. That shows up in mathematics as Fourier transform pairs. So we're starting to build the universe with a completely new model of reality. One that makes sense. One in which what I say is the same as what I see. And we've started with just the base simplicities, moving on to something more complex, and I am not contradicting the laws of physics because I'm using laws of mathematics to go from simple to complex. What happens in the energy, which can be completely uniform in the quark-gluon soup, I've got complete order. Now I've got to change order into more complexity, so I've got to use different language, order, complete uniformity, complete randomness in the entities directly related to temperature. So again, I've got a base pair between entropy and the temperature, and I'm changing order into complexity at the individual level. I'm making units. something new that I can count. So when I say zeros and ones, I can keep adding more and more different kinds of ones at the classical level, the large scale, more elements at the small scale. And zero doesn't mean there's nothing there. It means I'm not using that aspect. So a neutron doesn't mean there's nothing there, because it still responds to the strong nuclear force. It just means that the electromagnetic aspect, I'm not using it. So my zero, which I use as a placeholder, there's still the place. And zero doesn't mean there's nothing there, because it can be the sum of all the positive and negative numbers. So I've got different kinds of zero. A zero which means no positive and negative charge, or a zero which means the sum of all the positive and negative charge. So I get a completely different way of describing mathematics. My mathematical rules, I can now just look at the mathematics and say, well, instead of just saying -1 times -1 is +1, now I look at the rule. I look into physics. If I've got two magnetic charges, two magnetic poles, which are the same, the rule is they repel and I get positive volume from two negative components. And positive and negative are just relative to each other. They're either the same or different. So now I can say using physics why -1 times -1 is +1. I get positive volume. I just use the rules that I see in physics. So here is a completely new way to describe the self-assembly of the universe, using one single pattern based upon prime numbers, a relationship between two partners, relativity, and then more complex, 3. And in part 4, I'm going to show you the more complex parts of the universe, when I go from just building atomic nuclei, which all comes in pairs, acting against what happens at the gravitational level. So I've got a pair, the big acting against the small being generated, held in existence by what happens here, and this star being held in existence by what happens here, and it's all a relationship, a feedback loop, and it's the energy which also is using pure mathematics to describe its behaviour in the turbulence inside that star. So I hope that's starting to build a picture for you in which reality starts to make sense. See you in part 4. Bye bye now.